So hello guys, today we are going to discuss this problem, minimum flips to make A or B equal to C. So the question says is we are given three positive integers A, B, C, and we have to return the minimum flips required in A and B to make A or B is equal to C. So we can only flip digits or bits inside A and B only, these two numbers, and we have to make it after ORing these two, that is A or B as C, bitwise OR operation, and we have to find the flip operations, count the flip operations, and then return it. So, um, okay, so let us go to the example that how we are going to do it. So first of all, so what is OR operation? So let me tell you that. So OR operation means that if two bits are same, for example, 1 or 0 is 1, then 0 or 0 is 1, 0 or 0 is 0, sorry, and 0 or 1 is equal to 1, and finally 1 or 1 is equal to 1. So it means that if any of the bit is on, then the output will be 1. This is the OR operation, bitwise OR operation. So the approach to this problem is that we will be going to calculate. So first of all, we will convert these numbers to bitwise operation, to bits, bitwise representation, or rather we will do our calculations on the bit representation. Then we'll check. So for let's take this example first. This one, example one. Let's understand the example because after that it will be very easy. So we'll take the right bit of the resultant number which we want, that is C. So this right bit is 0, that will traverse one bit at a time. So we'll check that if it is 0, then both of these bits, that is the same positioned bit in A and B, should be 0. So if for example in this case both are 0, so we'll not increment our flip counts. For example, this is 1, then in that case we have to make it 0. So we'll not make it 0, but we'll count the flip or the output which we want to return as +1. And if both are 1, for example 1 1, so in that case we have to flip both the bits, because if we just flip this one, it will be 1 0 and the OR operation will still be 1. So we have to flip this one as well, and for both the cases we'll increment flip 2 times. So this is the case with 0. Now if 1 happens, so if bit is 1, so in that case we'll check the same indexed bits of A and B. So same indexed bit is here 1, and if any of the bits is 1, so we'll ignore or we'll not increment the flips. For example, here it is 1, so we'll not increment the flips here, and here it is 0, so we'll not consider it, because 0 1 is 1, or 1 0 is 1, or 0 1 or operation is also 1. But if both the bits are here 0, in that case we have to at least flip 1. So we'll either make this 1 and we'll increment the flip, and then we'll ignore the second one. So that's uh, the the approach. So let me do the dry run um, for this one. So here we have C, we have B, and we have A. So at index 0, C has 0, B has 1, and A has 0. So we'll be doing OR operation on A and B. So it will become 1 or 0. So it will become 1. So we have to increment the flips 1, because so it will become 1 because we have to make B as 0. That's fine. Now at index 1, the C is 1 and B is 0 and A is 0. Okay. So now we can either flip B or we can either flip A, because 1 or 0 is 1. So let's flip B. So this becomes 1 and our flips also increased by 1, that becomes 2. Now at index 2, we have C as 1, we have 0 and 1. So now in this case, 0 or 1. 0 or 1 is 1, so we'll not do anything, and we'll keep like we'll not increment the flips. So flips will remain 2 only. At index 3, the C bit is 0, B is 1, and A is 0. So 1 0 will become 1, so we have to flip this to 0. So this will become 0, and we'll increment the flip, so it will become 3. So now if we do a OR operation on all these bits, so 0 0 becomes 0. So this is the result. Let me write it down. 0 0 is 0, 1 0 is 1, then 0 1 is 1, and 0 0 is 0. So we got result same as C. So that means it's good. So let's go to the code. So now in the question there is a constraint given that the number should be less than 10 raised to power numbers are less than or equal to 10 raised to power 9. So if we are going to take an integer range, so in integer we have 2 raised to power 16 positive and 2 raised to power 16 negative. So this will not fit in. So we have to take long, because long or unsigned it, because long has a range of 2 raised to power 32 only positives. And this also says that it is greater than 1 and inside the positive range. So oh sorry, take it, it's 2 raised to power 32. So this is greater than 10 raised to power 9, because 10 raised to power 9 will have 9 zeros and 1 here. So this range can accommodate all these numbers. That's fine. So we have taken a unsigned integer and copied A, B, and C into it, because A, B, and C will not be negative. We have taken a number D as 1 because we'll be checking, uh, we'll be shifting the bits of D, and uh, we'll be doing the AND operation on this. So okay, so let me again go on to the notepad to understand it. So in order to perform a bitwise operation, or to check the bits, how we do it is we take a number D which is 1. So 1 will be something as 0001. So what happens is, we if we want to check what is the digit at index 0 in A, so we will do D and A. So A will be 0000010, and when we'll do D and A, that is D and A operation. So in AND, we remember that 1 and 1 is 1 only, otherwise all are zeros. 1, 0 and 1 is 0, 1 and 0 is 0, and then 1, oh sorry, 0 and 0 is 0. So here we see, if we do a AND operation, so what will happen is this 1 will become 0. So 0 0 is 0, 0 0 is 0, then this one 0 and this one, AND operation will become 0, and this 1 and 0 will also become 0. So this whole number becomes 0. So if the number is 0, that means bit at index 0 is 0. Now uh, we shift 1 in D to one position to right, so it will become this one. Now what will happen? We'll again do AND. So here 0 0 is 0, 0 0 is 0, 1 1 is 1, and 0 0 is 1. So it means if output is equal to D, if output is equal to D, then bit at index, that is index 1 is 1, right? And so on, we shift 1 to all way right, all way left. So next what we'll do is we'll shift D again 1 bit on the left, and finally we'll do it 1 bit on the left. So 1 will keep on going, and we will check this. So let's see the code here. So we have taken the output we will flip as 0. We will be doing till 32 because we have 32 bits in a unsigned integer. So at first place we are going to check the digit or the bit at the output. So C is our output, and we have taken NC1. So if bit is 0, in that case we will check that if A is 1, because this will return one operation, so we have to increment flips by one. And if b is also one, then we have to increment the flips by one. So remember, we have seen that if both the bits are one, we have to flip both the bits if the bit in C is zero. So if this is zero, bit in C is zero here, so we have to do these both flips. One and one, we have to make both zeros. So we have just incremented the flips, and then we have shifted one position to left. But if now after shifting we find D and C as equal to one, that is we found bit as one in output. Let's see here, and if any one of them is one, that is, if D and A is not equal to D or D and B is not equal to D, then in that case, if any one of them, if both of them, sorry, if both of them, this is and are zero, so we have to flip at least one bit. So we'll be incrementing the flip counter here, and finally we are going to return the flips. So this solution I have implemented in like uh, in multiple languages. So let me show you. Where is my solution? Okay. Um, okay, let me show you the submissions. So I have implemented in Python, Rust, and C++. So you can go to the any other solution and whichever you find suitable. So that's the thing. Thanks a lot. Have a good day.